Alright, so now let's talk about translations in functions. So here is the situation. Let's just say we've got a certain parabola. So let's just call it f of x equals 2x squared plus 4x, let's just say plus 2. Alright, so now, first of all, they can tell you, so they can say write down the equation of g if g, so they say write down the equation of g if g is f at x shifted 5 units to the left. So what you'll do is that you'll say g is equals, so you'll say g at x is equals to f at x. So if they say 5 units to the left, now I want to show you something. So let's just do this. So 5 units to the left is actually going to be like this. So now let me explain something. Whenever they put a number, right? So let's just call it k. Whenever they put a number inside the bracket, this number, whenever you see f at x or g at x or even h at x, whenever they put a number inside the bracket, that represents the horizontal shift, right? So it represents the horizontal shift, but in the opposite direction. So what does it mean? If you see something like g at x plus 1, then you know that instead of it shifting 1 unit to the right, it's actually going to shift 1 unit to the left, right? Or if you see something like maybe, let's just say you see h at x, right? So let's just say, let me just do this. Let's just say you see h at x is equals to x minus 10. Then you know that it will not shift 10 units to the left, but rather it will shift 10 units to the right. So whenever there is a constant inside the bracket, then it represents a horizontal shift. So now let's talk about something else as well. So let's just talk about something as well. Whenever it is now outside the bracket, right? So let's just do this. So if they put something outside the bracket, right? Whenever it's outside f at x or g at x or even h at x, right? Then it represents the vertical shift. So that's how it is. So now let's say they ask you to write down the equation of g if g is f at x shifted 5 units to the left. So what you're going to do is that you're just going to say g at x is equals to f at x plus 5. That's the first step. Now what does this mean? So notice that if this is f at x, if they say f at 2, what you would actually do is that wherever you see x, you would actually replace it with 2, right? You will say 2 squared plus 4 into 2 plus 2, right? So basically, if this was f at x, then they say f at 2, then wherever you see x, you will actually replace it with 2. So now it's the same thing. If this was, so now if we now have f at x rather, and then this is f at x f at x plus 5 rather. So it means that wherever you see x, you will replace it with x plus 5. So what it means is that it's going to be, so this is the long cut. I'm going to show you how to reason with this, but if you want to use the long cut, you can always do this. Yeah, so this is what we have. Okay, so but if this is the question, this is actually not the long cut. This is the only way to do it. If they say write down the equation, if it is shifted, you literally have to do this, right? But when it comes to the reasoning questions, I'll show you how to reason with this. So then they say, so it means that wherever you see x, you will put f at x. You rather put x plus 5, right? So this is what you will do. So it's going to be x plus 5. So I hope you get it, right? So if they say write down the equation of g if g is f at x shifted 5 units to the left, what you're going to do is that you're going to say g at x is equals to f at x plus 5. And then if this is f at x plus 5 just means wherever you see x, you have to replace it with x plus 5, right? So now we have to simplify it. So if you simplify it, I'm just going to use the shortcut here. This is just going to be x squared plus 10x plus 25 at the end, right? And then this is going to be, so let me just do this. So okay, so here I didn't change anything. So now I'm just going to distribute. So now when you distribute, it's going to be 2x squared plus 20x plus 50. And then here we're going to have 4x plus 20 plus 2. Alright, I hope I did not make a mistake because I'm just rushing so that we can get past this step. So then this is going to be 20 x plus 4x, which is going to be 24x. And then here we're going to have 50 plus 20 plus 2, which should be 72, right? So this is the new equation of f at x plus 5, right? But usually when they ask you this question, they usually make things simple. Sometimes they will give you the turning point form of the parabola. Alright, here is another question. So you are given this equation, then they ask you to write down the turning point of h. right? So they ask you to write down the turning point of h if h at x is equals to f at x minus 1. So what will you do? Okay, first of all, this is the turning point form of the parabola, right? So the turning point form of the parabola is in the form of a into x minus p squared plus q, right? Now p and q represent the x and the y values of the turning point, right? So therefore it means that the x value of the turning point is 1. We usually use the opposite with p, right? So if the turning point was at 2 is to maybe 10, here we'll end up seeing minus 2. Or if the turning point was minus 2, here we'll literally see plus 2, right? So we always use the opposite sign. Why do we use the opposite sign? Is because it's negative, right? It's negative for whatever value is there, so it's going to cause the sign to change. Okay, so P and Q are the x and y values of the turning point. So here we see that we see minus 1 and 4, but we know the turning point is actually 1 and 4, right? So this is the turning point of the original graph. So if they ask you the turning point of h, if h at x is equals to f at x minus 1, what you have to understand is that this is just the horizontal shift, right? So no calculations needed. So it means that it's going to shift 1 unit to the right. So if it shifted 1 unit to the right, then it just means the turning point is going to shift 1 unit to the right. So if it shifts 1 unit to the right, it's just going to be 2 is to 4, right? The y values don't change because the y values represent the vertical, x values horizontal, right? So notice it's a horizontal shift, so it's going to shift 1 unit to the right, so therefore this is going to be a new turning point. All right, so now here is a past paper question, right?
Just before I continue, if you want to be tutored, whether it is online or physically, whether it is the situation where you're struggling in maths or whether it is the situation where you're good in maths but want perfection, take a screenshot or save these details. Whether you're studying Cambridge, which is the UK curriculum, or whether you're studying NSC, which is the South African curriculum, or IEB, or native courses which start from N1 to N6, or any curriculum you're doing no matter which country you're at, we offer tutorials. We've got lessons and practice sessions 5 days a week. We also give you tests once a week so that we can check your improvement.
So what I'm just interested in is question 4.1.3 because that is in this topic that we're dealing with, right? Translations and reflections. So I'm going to go deeper. It's going to be even more interesting when we talk about reflections. So let's see. So now here we're given the graph, right? Okay, so here they said write down the x-intercept of h. So obviously we have to get the values of p and q first. So let's just do this question quickly. So yeah, let's just do it quickly. So this is going to be okay, fine. So this is the vertical asymptote. Okay, let me just get straight to the point. The answer is just going to be this, right? Because I'm dealing with translations and reflections. So this is the actual equation of of h at x, right? So we're going to have h at x is equals to this part. All right, so now if we want to get x-intercept, we know that x-intercept y is equals to 0. So it's going to be 0 is equals to 1 over x minus 1 plus 2. So let me take this to the other side. So if I take it to the other side, I'm going to have minus 2 is equals to 1 over x minus 1 plus 2. So this is what I have. All right, so now, what did I do? I meant this is what I have, right? Because we took this to the other side, this negative, and this is what we have. All right, so now this is going to be over 1. So when you cross multiply, it's going to be negative 2 multiplied by this whole thing. So we have to put it in brackets. And then this is going to be 1, right? So now we can literally divide by 2 so that I get straight to the point. But let me just use something that seems easier for most people, right? So this is going to be plus 2 and then equals to 1. So if I take that to the other side of the equation, 1 minus 2 is minus 1, right? So minus 1. And then it's going to be, if I divide both sides by negative 2, it means that x is literally going to be 1 over 2. All right, so it just means the x-intercept, it just means this part is 1 over 2 is to 0, right? So if they say calculate the x-intercept, don't stop here. You have to say is equals to 1 over 2 is to 0. So you have to show the coordinate. Okay, because it's a calculate the coordinate, right? So we know that it's going to be at that. So I just want to show you something. So it's going to be at half, and it makes sense. You see it in between 1 and 2, 0 and 1, I mean. So let me just manipulate it a little bit. So it's 1 over 2. All right, so now they ask for, they said, write down the x-coordinate of the x-intercept of g if g is equals to h at x plus 3. Honestly, looking at this, you should be able to, we don't need to take the long cut and put, right? If you want to take the long cut, this is the long cut. We know that it was x minus 1 plus, plus 2, right? So this was the original equation. So now if we say x plus 3, it just means wherever we see x, we have to replace it with x plus 3. So it's just going to be x plus 3 minus 1. And then it just means it's going to be 1 over x plus 2 plus 2, right? And then we'll literally have to find the x-intercept of this, and you'll get your marks. But honestly, it's a long cut. Let's deal with reasoning. So to deal with reasoning, this just means it's a horizontal shift. So it's going to shift 3 units, not to the right, but to the left. So it means that it's going to shift 3 units to the left. So all we have to do is just to say minus half minus 3, because it's going to be 3 units to the left. So this is going to be 0 0.5 minus 3 is minus 2.5. I know the answer is minus 5 over 2. Has to be minus 5 over 2. Yeah, so that is it. So now let's go for one more other past paper before we go to the reflections part. So let's just go there. So if they had put something like this, for instance, right, we know that the graph would have shifted 1 unit downwards, right? So because it's outside the bracket, so you just have to watch. So if the turning point, for instance, let's just say it's not a hyperbola, let's just say it's a parabola, because they won't ask you for the vertical shift of the hyperbola. If it was a parabola and the turning point was originally 2 to 4, if they say it's going to be h plus 3 minus 1, then we know it's going to be a horizontal shift first. It means it's going to shift 3 units to the left. So 2 minus 3 is minus 1. And then it's going to shift 1 unit down, which means 4 minus 1, which is 3. So this would have been the new turning point. So I hope you get it. So let's go further. Just before we continue, the video that contains the prices and the updated contact details, just in case these ones have changed, is found at the end of this video. Alright, so now here is rather the equation that we're interested in is g at x. So this is the equation for a certain purpose. Okay, why am I looking at this equation? Because of the next question that I want to deal with, that deals with translation. They said the graph of g is shifted 45 units to the left from to form the graph of h. So think of it, h is g shifted 45 units to the left. So how do we do it? We're just going to say h at x is equals to g at x 45 units to the left. It means it's going to be plus 45, right? So you have to understand this language. So if you want a horizontal shift, you just put it inside. If you want a vertical shift, you just put it outside. Then they said determine the equation of h in its simplest form. So now let's talk about that. So we already know that this is g at x, right? This is why I wrote down this equation, because this was g. So this is what we're going to use. So now notice, if this is g at x and now we have g at x plus 45, it just means wherever we see x, we have to replace it with x plus 45. So therefore, we're going to have, let me just write it here. So we're going to have minus cos 2, then we're going to have x plus 45, right? So notice here it was supposed to be minus 2x, but I replaced x with x plus 45. Alright, so now what are we going to do? So we're just going to simplify that. So it's just going to be minus cos 2 into x. So it's going to be rather 2 times x is 2x, right? And then we're going to have plus 90. So this is what we have, right? But this is not the simplest form. That's the interesting part. I just want to show you something. So this is what we have. So remember co-ratios, right? In co-ratios, we know that cos 90 plus x is equals to sine x, right? Negative sine x, actually. Yeah, so that's what we have. So what are we going to do here? So this is just going to be, so that's the thing. When it comes to translations in tree graphs, you have to remember to put it into the simplest form, and they're more likely to give you the one that will have correlations. So you have to know that cos 90 minus theta is sine theta. This one is the easier one, right? I just want to list all the 4 rules. And then we know that sine 90 minus theta is cos theta. And then cos, let's just start with sine. So sine 90 plus theta is also cos theta. However, when it comes to cos 90 plus theta, then we get a surprise. It becomes negative sine theta. Okay, so yeah, let's just try and write it much better. Let's just do this. So it's going to be minus sine theta. So that's what we have, right? So now, how do I memorize this? Plus, we know the basics of Christianity is the cross. When it comes to Christianity, sin is negative. So, yeah, so when it comes to plus, right, sin is the one that is negative. So sin is wrong, right? But how do they teach it at school? At school, this is how they teach it. At school, they say that um, 90 minus theta is in the first quadrant, right? Because this is 90, then minus theta, right? So it's in the first quadrant, smaller than 90. So in the first quadrant, everything is positive. But 90 plus theta is like 90 degrees plus an extra angle. So that goes into the second quadrant. In the second quadrant, cos, in the second quadrant, sine is positive. So whatever it changes to will be positive. But cos is negative in the second quadrant. Then whatever it changes to will be negative. Yeah, so that's the school part. So, but anyways, these are correlations. So when it comes to simplifications or translations in trig graphs, they are more likely to choose the one that will have correlations. So let me just arrange this so that it can make a bit more sense. So notice that 90 plus theta is negative sine. So there's another negative here. So I'm going to say negative sine. So sine 2x, literally. So this is what we have. And then this is going to end up being, what is going to end up being um, sine 2x. Yeah, so that's what we have. And then, yep, that is it. This is in the simplest form. All right, let's go to translations. All right, so before we go deeper, let's just take it a little bit back to old school, lower grades. So in grade 8 or 9, they taught you about reflections, right? So if they say reflect this to the y-axis, for instance, we know that the y-axis will be our mirror. So how will this look like? So this is going to end up, so if this is, so the same distance from the original to the mirror is the same. So y becomes like a mirror, right? If there's a reflect to the y-axis. So the distance from the original to the mirror is the same as the mirror to the reflection, right? So we're going to have the first point here, and then the distance here is like 3, and then, okay, yeah, it's going to be 3, then we're going to have 3 over here, and then here is going to be like 3 units as well, so 3 units as well, so that's going to be somewhere here. Okay, so this is just a rough drawing. So now the reflection will be something like this, right? So now when you notice what you would notice about the coordinates, this would end up being minus 3 is to 5. This one will end up being minus 2 is to 3. And then this one will end up being minus 3 is to 1. So notice that all the x values have changed the signs, right? But yet the y values remain the same. So then we know that when we reflect to the y-axis, x changes. But if they ask you to take this and reflect to the x-axis, what would happen? The x-axis now becomes your mirror, right? So now it means that the distance from the original to the mirror is the same as the mirror to the reflection, the original to the mirror, mirror to reflection. So it's like 3 units. So it's going to be 3 units here, and then here's like 5 units. So it's going to be 5 units over there. So now if we draw this triangle, let's just do this. So this is actually how it's going to look. Okay, fine. So what I did, not cool. Let's just try it again one more time. So this is just how it's going to look like. Something like this. Okay, yeah, so something like that. Okay, so now if you check the coordinates, so the coordinates this time is going to be 3, so the x values remain the same, but y changes, right? And then this side is going to be 3, but then minus 5. So instead of 5, we now have minus 5. And then this side is going to be 2, right? So let's just change it a bit. So it's going to be 2 and minus 3. So what you would notice is that when you're reflecting to the x-axis, y changes, right? So I just want to use this as the basic. So this is very important. How that when you reflect, so you'll see this is very important. So when you reflect to the x, y changes. But if you reflect to the y, x changes, right? All right, so now let's move on to the next level. Let's talk about reflections. So let's just say we've got a certain graph. Let me just do this. So let's just say we've got a certain graph. Let's say this graph is called f at x is equals to, so let's just say we've got 2x squared plus 4x. Alright, so now it said h at x is the reflection of f in the y-axis, and they said find the equation of h. What you'll do is that you will say h at x is the reflection of f in the y-axis. Now I'm going to explain why I'm doing this. Now notice, remember, when we're reflecting to the y-axis, x changes the sign, right? So whenever you see this, this means that it's a reflection of the graph to the y-axis. Or if you have the reflection of the graph to the y-axis, you can simply just put negative x, right? So when we reflect to the y-axis, x changes. But now if it was the reflection of the graph to the x-axis, y would change. So how would you do it? So we know that it was going to be negative y. But remember, f at x is the same as y. So therefore, it's just going to be negative f at x. So just to cut it short, whenever you're reflecting to the x-axis, y will be negative. So it's going to be like this. But when you're reflecting to the y-axis, x is going to be negative. So let's talk about this. So now, if they said h at x is the reflection of f to the y-axis, what you're going to do is that you're going to say h at x must be equals to f of minus x. Now, if it was f of 2, what you would do is that everywhere you see x, you would put 2. But now this time is f at minus x, meaning that wherever you see x, you put minus x. So what you're going to do is that you're going to say it's going to be minus x all squared plus 4 into minus x. So we have just replaced x with minus x. So now we'll simplify the graph. So if they said write down the equation, so this is what we'll do. So we have to simplify it as far as possible. So then this is going to end up being everything squared is positive. So it's still 2x squared. However, here it's going to be negative. So this is the new graph. So before I deal with some type of questions that can come out, let's go for another one. So let's say they say h at x is the reflection of f in the x-axis. So we know that if we reflect to the x-axis, y will be negative. So because y will be negative, the negative has to be outside, right? So this is like saying negative y. So I hope you get it. That is the same as saying negative y. So now what you'll do is that since it's negative f at x, it just means that you have to replace f at x with this equation since this is f at x. So it just means that you'll say minus, then you're going to say 2x squared plus this stuff. And then now when we distribute, it's going to be 2x squared minus 4x. And there we have it. Alright, so now let's deal with the hyperbola. So this can also come out in the hyperbola. The hyperbola part becomes interesting. Here is the situation. So let's say h at x is the hyperbola, because they like calling it h at x, but not always. So here is a certain hyperbola that we have. Let's just rather that we're given. Let's just say we're given something like this. So if they say g at x is the reflection of h at x and the y-axis. Let me start with the easier one first. So let's just say they say g is the reflection of h to the x-axis. Then they ask you to write the equation of h. Well, if they say g is the reflection of h, you will tell them that g is equals to, so they say it's the reflection of h to the x-axis. So if they say it's the reflection of h to the x-axis, what you'll do is that you'll say it is minus h of x, right? So y has to be negative because it's the reflection of h in the x-axis. So this one is quite simple. This one we know that it's going to be, so let me just do it step by step just to avoid confusing anyone. So this is just going to be minus 2 over x plus 1 plus 2. So this is the new equation. Now let's go for another one. Let's go to another level. What if they said it was the reflection of h to the y-axis? So if they say it's the reflection of h to the y-axis, this time we'll make x negative. Now I'll show you something interesting. So now notice this is going to be 2 over. So wherever we see x, we have to replace it with minus x. So it's going to be minus x plus 1. So the graph, the equation rather, will not end here. I'm sure you have never seen a hyperbola that has negative x at the bottom, right? So what do we do? How do we get rid of it? So this is an interesting one. In order to get rid of it, here is a skill. What you'll do is that you'll factorize negative. For instance, let's just say we've got something like minus 2x squared plus 4. If you want to, you can factorize negative. When you factorize negative, you'll just say negative 2x squared divided by negative 1, which is just 2x squared, right? And then positive 4 divided by negative 1 is negative 4. So this is factorizing negative. Where you factorize negative, where you take negative outside, right? So that's what you will do. So you will take out negative. So now, and just to cut it short, everything will obviously change the sign. So if this is negative, it will be positive. If this one is positive, it will be negative. So that's what we have. So now we're almost done. So now here is the situation. So what are we going to do? So now we just shift it on top. We are literally allowed to do it because notice negative 4 over 5 is the same as 5, rather it's the same as 4 over negative 5. Because both of these, if you type in a calculator, you'll see the end result will just be negative outside, right? So if a fraction is negative as a whole, it just means one of the values was negative. So what you're allowed to do is that you're allowed to just shift it upwards. So then it's going to be negative 2. Then we've got x minus 1 minus 2. And there we have it. This is our equation. So now let's deal with some interesting questions. Let's start with the basic one, then we go higher. So now, if they ask us the turning point of this, it's quite simple, right? So let's just start at the very beginning. So the turning point of this, because this is the turning point form of the parabola, right? So which is a into x minus p squared plus q, right? So p and q are the x and y values of the turning point, right? So it means if we see this and p is always the opposite sign that we see here, so it means that it's going to be, the turning point is going to be 1 is to 8, right? If it was positive 1, we would have said negative 1 here. So far this is the turning point of the original graph. Now if they ask us the turning point of h, if h is equals to, so they can say find the turning point of h if h is equals to f at x minus, okay, let's just do this. Let me just do this. Let's just say h at x is equals to minus f at x minus 2. So what are we going to do? So now if you see this, it means that it was reflected somewhere, right? So y is negative, meaning that it was reflected to the x-axis. So we know that it's going to be reflected first. So it's going to be reflected to the x-axis, right? And then afterwards, this tells us it's a shift. So we know that it shifted 2 units to the right. So then it means it shifted 2 units right. So what are we going to do? So all we have to do is to reflect this to the x. We know that when we reflect this to the x, y changes, right? So it means y will become negative. So far we have this. Now we have to shift it 2 units to the right. So it means we're just going to say this plus 2, right? Notice I didn't minus 2. Minus 2 only tells us that it shifted 2 units to the right. However, when it comes here, I have to plus 2, right? So it means that it's going to be 1 plus 2 because it has to shift 2 units to the right. And then it's going to be minus 8. Okay, so here I just wrote it weird. So 1 plus 2. I'm not saying you have to do all these steps. This is just to make sure there is understanding. So this is what we have. So let's go for another one. So afterwards I will go to some other types of questions. So now let's say they ask you to find the turning point, right? So the original turning point is 1 is to 8. So they ask you to find the turning point of h if h at x is equals to f of minus x plus 2. So now what does this mean? This means that it's reflected to the y-axis because x is negative. So if reflect to the y-axis, x becomes negative or x changes the sign. So this is what we have so far. Then this means it will shift 2 units upwards. So then it means it's minus 1, then 8 plus 2, which is 10. So this is the turning point of h. Alright, so let's just go for one more, then I go for another type of question. So let's just create something crazy. Let's go for something like this. Alright, so what does this mean? Obviously, I don't think this will come out in the exam. So if h at x is this, now they ask for the new turning point, right? So this means that it's reflected to the y-axis and then it's reflected to the x. So if we reflect it to the y-axis, then it means x is negative, right? So it means so far we're going to have this. And then if we reflect to the x, it means that rather if here we reflected to the x, meaning that y is negative, and then now we're reflecting to the y, meaning that x is negative, so it means it's negative, right? So now we have to shift it 2 units to the left, rather to the right is the opposite. So it means it's going to be minus 1 plus 2, and then here I've got that. So minus 1 plus 2 is 1. So eventually this becomes 1, so we're going to have 1. And then now we have to shift it 10 units upwards. So minus 8 plus 10 is 2. So the new turning point is 1 is to 2. Alright, there we have it. Now let's go for another type of question. Let's go for another level. Let's say we are given this trigonometric graph, and then they say describe the shift from this graph to, and then they give you another graph. Let's call it z(x). So they give you z(x) and they say this is equal to 2 into sine x plus 30 plus 1. So I'm starting at the easier level of this type of questions. So now, how are you going to, what are you going to do? If you compare the graph, you'll notice that the only thing that changed were the signs, right? So if you see that the sign of everything changed, then you know that it was actually minus f at x, right? So this means that it was reflected to the x-axis because y is negative. So that's how you interpret this type of questions. So you just compare them and you see what changed, right? Using the rules of either the shifts, right? Maybe it was the shifts. Okay, let me just draw this nicely. Sometimes it can be the situation where there is a shift. Sometimes it can be a reflection, right? Sometimes it can even be the combination of them. So let's go for another type. What if they had given you, let's say, h at x? They said h at x is, then they say is 2 sine x. Okay, let's do this. So they say 2 sine x plus 30. Then they said minus, they say plus 2. Or let's just change it to, let's just say minus 2. So what would you have said? The minute you see that the sign of the one in front has changed, right? Instead of the constant, let's just say you see the sign of the one, the coefficient in front changing, right? Then you already know that there's still a reflection. So this is still reflected to the x-axis, meaning that y is negative. So it means that we are supposed to have a graph like this. So this is supposed to be our graph, right? We're supposed to have, let's see, I mean, not this, but this is supposed to be our graph, right? Where the signs change, right? So this is supposed to be the graph when it's reflected to the x-axis, right? So what has changed? So now the problem that we have is that here it's supposed to be plus 1, but here's minus 2, right? So if this is reflected to the x-axis, this was supposed to be how the graph would look like, but so far we have it looking the same except for this part. So what we have to do is we have to find out how did it change from plus 1 to negative 2, right? So from plus 1 to negative 2, this is like minusing 3, because 1 minus 3 is negative 2. If you want, you can even solve for x, but it's not necessary. If you want, you can solve for x. You can say x plus 1 must give us negative 2. If you take that to the other side of the equation, x is minus 3. So this tells us that it shifted 3 units down, right? So what you'll do, the conclusion is that you'll say it is reflected. So it is reflected to the x because y became negative first of all, right? By us seeing the sign here changing, we see that y became negative. So it's reflected to the x, then it shifted. So it shifted 3 units down, right? So 3 units down. So forgive my handwriting there. I usually don't like writing. I like calculating. I like writing and coding. So most of my students know this. Okay, so that's what you do. So you first check if you see the sign exchange, find out what would it have been if it was reflected to the x-axis, right? And then from there, if the constant is not the same, then you just find out the shift. So let me give you another one. So here is another one. Here is another example. So they say describe the translation from this graph to this graph. So what is different? Everything is the same, right? Except for this stuff. So what does it mean? So now you have to check what changed here. What changed here is that we added 30, right? So basically, this is the same as saying minus 2 sine x plus 30 plus 30, right? So let this 30 be this one. So here I put it close to x because I want you to see something. So it's basically the same as doing this, right? So this is actually the same as saying f at x plus 30. I want you to see that because if I said it must not be f at x plus 30, it means wherever I see x, I'll have to replace it with x plus 30. So basically, what I'm trying to show you is that if it's a plus 30, then it means it was shifted 30 units to the left, right? Remember, p is always opposite, right? Because the full form of the tree graph is a sine k. Some people use p, right? Some students use p, some students use k. Okay, so I preferred k because I learned it this way. So, but it's still the same. Even if you put b, then it's going to be x minus p plus q, right? So this p tells us the horizontal shift, but always in the opposite direction. So if we see plus 30, we know it's minus 30, minus 30 plus 30. So therefore, if you see that it was 30 that was added, then it means it is shifted to the left instead, right? So that's how it is. So let's just go for another one. Here is another one. Let's say they instead gave you sine x minus 1. So we see that the only thing that is different is that there was 30 here, but now there is nothing. What does it mean? It means that we actually subtracted 30, right? So it means that we subtracted 30. So if we subtracted 30, it means that we shifted 30 units to the right this time. So let's go for another question. So let's say they give you this as the original graph, then they say describe the shift from this or describe the translation from this, and then they give you something. So let's say they give you something. Let's say they give you um, okay, so I'm just thinking of one type of question that I'm going to set after this one. So let's say they give you something like this, 2 sine, and then they give you x plus 90, or let's just say x plus 15, and then they say plus 1. So now what you would notice is that first of all, this is um, this is different, right? So if you see that the signs have changed, it's the same as reflecting to the x-axis. Let's prove it. Because if we reflect it to the x-axis, it is y that becomes negative, right? But now notice, f of x is this whole stuff. So if I were to substitute it, I'll end up having minus 2 sine x plus 30 minus 1. So that's what I have, right? I just put this in place of f of x because f of x is this stuff. So if I distribute, I'm going to have 2 sine x plus 30 plus 1. So therefore, if you see that the signs have changed, then you know it was obviously reflected to the x-axis. Alright, so now we know it was reflected to the x-axis. But now we also see another change. Another change is this part, right? Instead of 30, we now have 15. What does it mean? It means that we minus 15, right? So if you want, you can even solve for x again. You can even say 30 plus what or minus what. Let's just say 30 plus what. 30 plus what gives you 15. So now if you take that to the other side of the equation, we're going to have 15 minus 30, which is equals to minus 15. So there we know that, therefore we know that we're minus 15, right? So from 30 to 15 we minus 15. What does this mean? It means that it shifted because it was minus 15, so it means it shifted 15 units to the right. So the conclusion of this is that you'll just say reflected, to the y, so it's reflected to the x-axis rather, because y is what became negative. So forgive my handwriting there. We reflected to the x-axis, and then we also it's also shifted 15 units to the right. So shifted 15 units to the right. So that's what you will tell them. So forgive my handwriting there. I'm sure it looks like Greek. All right. So that's what we have.